Hi. Okay, we're going to talk about exception handling. So exception handling is a way of dealing with errors. If you don't have exception handling, what you wind up doing is just a bunch of if statements. So every method you have will return a value, and that value could indicate an error condition. And it's really easy to forget to check those error conditions. Exception handling has been around for a fair amount of time. Lots of languages use it. There are going to, as usual, be specifics about how the exceptions work in different languages. Java has I guess you could call it novel. I don't know all the languages, so I don't know for sure where it all came from and all that. But Java has this fairly novel idea of two different kinds of exceptions: checked exceptions and unchecked exceptions. We'll go into that. Other languages don't necessarily have that. Some may. A lot don't. So at the top of the hierarchy for everything is Java-lang object. At the top of the exception hierarchy, there's throwable. So if an exception exists, if it's something that can be thrown, it ultimately has to extend from throwable. This is different than a whole bunch of other languages where you could just throw anything you want. Java mandates, forces that you have a hierarchy for your exceptions, and throwable is at the top. Unless you really know what you're doing, and you don't, um, you'd never actually use the word throwable. I've probably used it twice since 1995. Um, and I understood all the ramifications of using it, and I chose to do it. And I was unhappy about having to do it, but there were situations where I actually had to do it. Way beyond the scope of this course, you should never write the word throwable in your programs. There are two main classes underneath that. And under exception, there's one more, which is runtime exception. So at the top is throwable, then we have error, then we have exception, and then we have runtime exception. They are all used to represent different things, different kinds of failures. So errors indicate something that you, the programmer, shouldn't even be concerned with. The virtual machine ran out of memory. There's nothing you can do about that except rerun the program, giving it more memory, or fixing your code so that that doesn't happen. Use less memory. Usually the solution is to rerun the virtual machine, passing in more memory. um, it could indicate something like you've got a corrupt class file. It could indicate something like you tried to load a class file, the file existed, but it's compiled for a newer version of the virtual machine, and your virtual machine can't understand it. A whole bunch of things that you, the programmer, have nothing to do with. They're environmental issues. Exception, those are used to indicate that you, the programmer, made a mistake. Sorry, that's wrong. That's what runtime exception is. Exceptions are the exception is used to indicate things that you expect to go wrong. I tried, and a lot of them center on files. So I tried to open a file, it didn't exist. I tried to open up a file and it didn't have permissions. I tried to save a file, but we ran out of disk space. I tried to read from a file, it was a networked file, and the network drive went away. All sorts of things like that. Right? So these are things that we expect to go wrong. We hope they don't, but if they do, we have to deal with them. And then the last one is runtime exception, which indicates you, the programmer, made a mistake. Null pointer exception, array index out of bounds exception. You saw me use one the other day, a legal argument exception, right? You passed a parameter that's not allowed. So I mentioned checked and unchecked. So I'm going to put a check mark beside the checked ones. So this is checked and this is checked. So if you extend from throwable, which you shouldn't do, but if you extend from throwable, you're a checked exception, unless you're error. If you're error or a child of error, it's an unchecked exception. If you extend from exception, it's a checked exception, unless you extend from runtime exception. So down here, we have null pointer exception. Null pointer exception is a runtime exception. That means that null pointer exception is an unchecked exception. File not found exception, I'll just shortcut it. File not found exception extends directly from exception. It is a checked exception. So what's the difference between checked and unchecked? I sort of already covered it. This is something a programmer can't deal with. This is something that a programmer needs to fix. No properly running program, no properly debugged program should ever generate a runtime exception. Okay? That would be the way Java, the creators of Java intended it. This gets abused. I will talk a little bit about the abuse, but I will not teach the abusive way. I will teach the proper way, the way that they, as best I understand it, intended it to be used. So runtime exceptions should never occur except in a program that is not properly debugged yet, not properly tested. Errors can occur at any time, and they're out of your the programmer control. So that's why runtime exception and errors are unchecked. And we'll see the mechanics of unchecked exceptions and what that means later on. But keep this hierarchy in mind. So you need to know throwable, error, exception, and runtime exception. I expect you to memorize those and that hierarchy, and which ones are checked and which ones are not checked. I'll talk in generalities using English, and then I'm going to go into the computer and I'll make I'll do everything I'm talking about in code. So I'm not going to write code up here, but I'll write some words, the important words. And I'm going to do a two-part thing on exception handling, one with the common stuff and then one with the less common pieces. So in general, we're going to try something that could fail. If it fails, we're going to throw a new exception. If that exception is going to be thrown outside of the method and it's a checked exception, we're going to have to declare that the method throws it. That way things know what checked exceptions they have to deal with. And the last thing you do is catch it. There's one more word. I'll bring it up here just so we have it, but I'm not going to cover it right now. The last thing you do is finally. So we will see this later. But you're also responsible for understanding and knowing what all these words are, okay? We'll see it in code, but again, just to reiterate, you try something that might fail. You try to open up a file, and if it isn't found, it'll throw the exception. So when it fails, or if it fails, it throws an exception. If that's a checked exception, the method has to say throws. You can catch an exception, and there's something to do with finally we'll talk about later. That's it. You need to know the hierarchy. Throwable, error, exception, runtime exception. Exception. So you need to know this hierarchy. You need to know that throwable and exception are the checked exceptions, and error and runtime exception are the unchecked exceptions. You need to know that you try something. If it fails, you throw usually a subclass of one of these exceptions. Your method, if it's a checked exception, has to declare that it throws it. And if it's a checked exception as well, you have to catch it. We'll talk more about catching things later. And finally, we'll talk about another time. So memorize this. You do need to understand it. This is all stuff that you should be able to recall instantaneously in case of a test. But when you're programming, you're going to need to know it. We use exception handling a lot in Java. One other thing, I've been doing Java since 1995. When I deal with exceptions, I have a very simple process that I follow. I don't do anything. unless the compiler tells me to do it. So if I throw an exception and it's a checked exception, the compiler is going to tell me, hey, you didn't put in throws. Okay, I'll deal with it. And how I choose to deal with it will depend on the situation. But basically, I just turn my brain off, don't even think, write the throw or whatever. It tells me, hey, you need to put in a try. Hey, you need to put in a catch. I intellectually know when to do those things, but honestly, I don't bother. I literally just let the compiler tell me what to do. Give me a test, I'll be able to pass the test, no problem. I do understand it all and all that, but from a practical point of view, to make sure I do everything right, I actually do as little as I can and rely on the compiler to tell me what I'm doing wrong. And at those point in time, it's when the compiler tells me something, that's when I make the decision on what to do. That's like 95% of the time is how I deal with things. So I encourage you, two things. I encourage you to learn all of this, fully understand it all, so you can actually, understand what it's doing, you can explain it, you can pass the test, all that kind of stuff. I also expect you to not do anything the compiler doesn't tell you to do. If you start doing things the compiler doesn't tell you to do, it's a chance to lose marks, which you probably don't want to do, and you'll be learning to do things the wrong way, which I don't want you to do. So when we're actually coding, I am going to encourage you to not try to be smarter than the compiler, because if you get it wrong, you'll have done the wrong thing, and the compiler will happily tell you when you're doing it wrong. Okay? So we're going to switch over to code, and we'll see how all of this works in practice.
We are going to cover the basics of exception handling with this video. I'm going to do 2 more exception handling videos for the code. One, there may be videos that go along with the whiteboard too. This one's going to cover the absolute bare basics. The next one's going to cover some more advanced features, and the last one will cover the more esoteric features. You really need to understand this video for sure, 100%. So let's start off by just doing some things that will generate exceptions. So right now, what's the value of hello? When I ask a question like that, please pause the video and think of your answer, and then unpause it. I'll give you the answer. So the answer is it's null. It's null because it's declared in the class level, and as an instance variable or a static variable, which is what I'm going to wind up using here, they wind up being null. Just by default, just the way things are. So let's go with this. We'll system.println hello, and we'll also print the very first character out of hello. This is a problem because hello has no characters because it's null. So this line should print out null, and this should cause it to crash. And it printed out null, and it crashed because of a null pointer exception, because we tried to call a method on something that is null. Lesson number 1, don't call methods that are being passed as parameters into things, right? Always make a temporary variable. So, and I'll explain why in a second. I'll show you how first. Okay, so that's how. And I'll run it again after once I show you this. So this crashed on this line 8, but it's moved now. So it crashed here. And so it could be anything before a dot, right? So a class can't be null, but out can be null. So println.out, well, if out somehow is null, that's the cause of the crash. The other choice is hello is null. So I don't know if it's hello or out that is null, right? In this case, it is telling me more information. It's telling us it's because main.hello is null. That's awesome. That's a relatively new thing that's come into play in this version of the Java virtual machine. If you're writing a program on Android, for example, it may or may not tell you that. I don't believe it does. I was actually shocked to find that it did this a while ago. So I don't know when they added this. I really love that they added it because the amount of time people wasted trying to figure out what was null. However, that's one reason why you should never pass a parameter here, because if you're causing dealing with multiple things with dots before them, any one of those can be null, and your environment may not tell you. The other reason not to do it is, what if I want to use C multiple times? I'd have to call char at 0 multiple times. I only want to call it once. So I prefer to um, make a variable instead of passing parameters in. The last thing why we want to do it is if we're debugging, and I'll show you the debugger later. I'm able to just put my mouse over the C and I can see it. If it's done by hello.charat, it's a much more involved process that I may not even be able to use. So little programming tips for you there. So now when we run it, it's still going to crash. It's still going to tell us that hello is null, so at least we know what it is. And it's crashing on line 10, right? And we can see that hello could be null, right? So that's our problem. That's a null pointer exception. Notice the compiler didn't tell me to do anything, right? So here's another example of what we can do to make it fail. We'll talk about argv another day, the command line arguments, but and I'll show you how to set them. But don't worry about that right now. So argv is a parameter here. It's an array. Arrays all have length. I'm going to get the first item out of there. It's not going to work. It's going to print out 0, and it's going to crash. It prints out 0, and it crashes with an array index out of bounds exception, right? The length, and they finally tell you the length too, right? So they told you the length is 0. We're trying to get 0 out of something that has nothing, right? This length would have to be at least 1 for this line to work. These are the kinds of things that I'm very happy to see put into to Java, because they didn't used to tell you this kind of stuff, and it was such a time waster. So they've added it now. But again, it won't exist on all your machines, virtual machines, and it doesn't do anything to stop it from happening, right? The fact that it told you what the problem is just makes your life better. So we've seen null pointer exception, we've seen illegal array index out of bounds exception. Those are both, if we look at them, this then extends an index out of bounds exception, which extends runtime exception. That's a null pointer exception, right? If we were to go look up null pointer, that's an illegal argument exception. If we were to look up that's a runtime exception. If we were to look up null pointer exception, we would find the same thing, that null pointer exception extends runtime exception. Those are then unchecked. So I'm going to do the thing slightly differently. I'm going to call a method. And we'll pass in true or false here. So if we pass in true here, it's going. I did find out that there is, in the preferences here, under, can I find it again quickly? There's a way to turn off that, it might be editor. Nope. I'll have to find it again. There's a way to turn off that little, this little thing here, which I will do because it causes students confusion. It's just telling us that that's the name of the parameter. If I change this to whatever, it'll change that to be whatever. But it's just a convenience for you, the reader, but it does confuse students. So we'll turn it off in the future. Sorry. So we're going to call foo. If we pass in true, it's going to print out that it's going to throw. If we pass in false, it's going to print out that it doesn't throw. Well, I can run that. It'll print out it's going to throw. I can change this to false. And we'll see that it's not going to throw. So I'm going to throw a new exception. Very, very, very important. I do not ever want you to actually use the word exception. I forgot to mention that in the other video. You should never use the word exception except for extends exception. We'll talk about that in a later video. But if you type in the word just exception by itself, that is horrible. However, we don't have enough information yet to deal with subclasses, so we'll see that in the next video. So this is the one and only time I'm going to break that little rule. Okay. So we're going to throw a new exception, and it's unhappy because it's telling us, and this is the compiler telling us if we try to compile, it's telling us that we are dealing with a checked exception. Remember, exception. This is a checked exception. We're throwing it, but our method isn't declaring that it throws it, and we're not catching it. It is, and we'll talk more about catching later, but the ins and outs of it. But it's bad form to both throw an exception in the same method that you catch it. So generally, if you say throw, you're going to declare that your method throws exception. I'm going to show you in the next video why this is horrendous and you should never do it. Okay, please never ever actually do this. But again, for this one video, I'm going to break my rule. And now the compiler is complaining because we haven't dealt with this. So we have two choices. We can say that this throws an exception, and that's horrible. The problem is that when you have main throw an exception, your program crashes. We don't want our program to crash. The lowest mark I ever gave it wound up being 0, but the lowest mark I ever gave back to a student was -30. That's because their assignment didn't do what was asked, and it crashed three times while it was doing it, and each crash was worth 10%. The problem was that they had thrown from main. So do not throw from main. Consider this to be the use case of making a pacemaker. If the exception gets thrown from main, the pacemaker stops working and the person with the pacemaker dies. So we never want main to throw an exception. That's a bad idea. The only time it's okay for main to throw an exception is if it's a runtime exception, and the only time it's okay for main to throw a runtime exception is when you're still developing it and you haven't tested it thoroughly and you haven't fixed all the bugs. That's the kind of thing that we're talking about. So a properly debugged program should never crash. So we can't have main throw the exception. Right? Can't say throws the exception. So our only choice is to do a try catch. And I'm just going to print out the stack trace for now, just so we can see it. But presumably I would print out a nice helpful message to the person. Like, please take your pacemaker into the hospital to get checked because it's going to have a problem. So we say that it doesn't throw here, and if we change this to true, it's going to throw the exception, and it's going to tell us that it was throwing. We had this problem here, and that ultimately came from line 21 was here. So this is called a stack trace, and you can see exactly what happened. So we threw an exception on line 21, and it got caught on line 7. Right? So it went from here into the catch block. We're going to see more on how the catch process really works later on. But this is the bare minimum, right? So we try something, this is the something, that could fail. If that thing fails, it's going to throw an exception. If it's a checked exception, the method has to declare that it throws the exception, and ultimately something has to catch it. Right? The other interesting thing here is if we put in a couple of print lines, we change this back to false. So what do you think the output of this is going to be? We're going to print out before foo. We're then going to call foo passing in false, which is going to print out no throw. Then we're going to come here and print out after foo. And what if we did true instead? So true, we're going to print out before foo. Then we're going to come in here, we're going to say going to throw. We're going to throw the exception, and we're going to skip past here. We're going to go directly from well, actually, we're going to go essentially directly from this line to this line. So here it is without throwing the exception. Before through, no throw, and after foo. And if we change it to true, it will be before foo, we're going to throw, and then the stack trace. Before foo, going to throw, the stack trace. So we see that it skipped over this line here. And that's exactly what we want it to do. Basically, we're saying if this line fails, there's no possible way to execute the following lines because the following lines are, invalid because they needed foo to work. And then you have to try and figure out what to do about that. So this is the bare minimum. This is the basics of exception handling. And we will learn some more advanced things as we go. And there's going to be at least 2 more videos.